Hello, star friends. Welcome to EarthSky. I'm Deborah Byrd. A star has to be pretty special to earn the name Wonderful. And the star Mira in the constellation Cetus the Whale has a name that literally means wonderful in Latin. I'm here with my friend Bob King, aka AstroBob, to talk about the star Mira.
How are you?
There he is. Hi, Bob.
Hi.
Uh, Hi. So tell us, what's so wonderful about Mira?
What's amazing about Mira, to just the visual observer, is that there are times, long spans of times, when you cannot see this star. It's just a blank spot in its constellation. Then, all of a sudden, it seems like it's there. And Mira is there right now. You can go up, you can see it just with your eye, and you don't need any telescope or binoculars. So it kind of appears and disappears, and that makes it remarkable and wonderful.
And that's how it got its name, right? That the early stargazers looked at it and they were so used to the heavens being unchanging. And suddenly here's this star popping in and out of view.
Yes, actually, an observer was using it to compare brightnesses of a planet. And then when they looked at it later, realized, well, wait a minute, that star's brightness has changed. And they became aware, this was back in the 1500s, they became aware that this star was actually changing its light. It was the very first, what we call a long period variable discovered, and that was back in 1596.
So let's look at Mira's location in the night sky. Tell us about this, Bob. If somebody wants to find it, where should they start?
Well, best time to start is as soon as it gets dark. So early in the evening, 6:30ish, thereabouts, 7 o'clock, whatever, in that time frame. And it's high up in the southwestern sky, so it's easy to see. It's in a big old faint constellation called Cetus the Sea Monster. But to find Mira, you just use two bright, easy objects. You use the Pleiades, otherwise known as the Seven Sisters, and nearby the bright orange-red star Aldebaran. And you just connect those two bright objects in the triangle you see here on the map, stretch it out to the lower right, and the first star right there at that third apex, that will be Menkar. And then down from Menkar, that's the brightest star in Cetus, you just go about one fist and it will bring you to Mira. So just follow down that line from Aldebaran through Menkar, and it'll be right.
Yes. And you really do need a chart for this one.
You do. It's not so bright that you can just go out and see it with, like, oh, there it is. It's, not like a supernova or something. If you're familiar with the Big Dipper stars, Mira is right now, it's about one level fainter than the Dipper stars. So easy enough to see, but, you're going to have to use a chart to find it.
And this star is even better from the southern hemisphere because it's going to be more overhead from the southern hemisphere. And so if you're in the southern hemisphere, our recommendation is that you use the website Stellarium online. Mm-hmm. And we will put a link to Stellarium into the post description, and you can put in your location and you can put in the name Mira, and it'll pop up for you and show, Mira with respect to your horizon, no matter where you are on the Earth. So it's a good tool to have. Bob, do you remember when you first noticed Mira changing in the sky, and what that feel like?
I'm sure I was a teenager. I don't remember the first time, Debbie, but what I do remember are the several times when I haven't paid attention to Mira, and it's been faint, invisible, just a missing place in that constellation. And then I'm doing something else at night, and then one night I look up and go, whoa, Mira's back. I mean, I honestly say that out loud. Mira, you're back again. And that actually happened this time around. It just returns kind of with a suddenness almost. And since then, I've been tracking it and estimating its brightness all along here. So that has happened several times to me. So that element of surprise that Mira brings because of the changing brightness really caught me. And, that's one reason I think it's such a wonderful star.
I know, and you're not alone in that. So, that's what you meant, right? When you said that this star is waking up now.
Yes, of course, it's always there, right? We know that. But its light changes over time, over a period of about 11 months, 332 days. It goes from being faintest to maximum brightness and then back to faint again. So it goes through the cycle constantly over the decades. And
And
when it's near its
let's go
brightest,
back to that other illustration.
yeah.
Natalia, can you put us back? Yeah, there we go. You said it's like breathing, right?
Yes, it's like if you can imagine yourself just inhaling and then exhaling, something similar is happening inside of this star. It's not in equilibrium anymore. Unlike the sun, which keeps a stable size, Mira is a very ancient star, older than the sun, and it's sort of out of balance. And so it overshoots itself. What happens here is that gravity pulls the material of the star inward. As it does, that material heats up in a layer beneath the surface, gets so hot, builds up so much pressure that it has to release. It finally does. It releases that pressure and causes the star to expand and become larger. Now, what happens? It cools as it becomes larger. Once it cools, gravity pulls it back in again, and then it begins to heat up, and then the cycle begins new. And like I said, the whole thing takes about 11 months. So it's sort of it's an instability within the stars, a lot of physics involved because there's all these different layers of burning hydrogen and helium, and they're causing this star to not be, or causing the star to be out of balance, creating the pulsations.
And for those of you who like to look at things numerically, let's look at the graph. Yeah, this one. It shows a measurement of Mira's light getting brighter and fainter over time. And this particular graph goes for 10 years. Members of the American Association of Variable Star Observers made these observations that made this image possible. And I
Yes.
want to mention that because Mira's not the only variable, right, Bob?
No, there are hundreds of these. They call them Mira type variables. And Debbie, I'm looking at this curve and I'm thinking this resembles my life in a way. Ups and downs, ups and downs. But yeah, there are lots of different variables in different classes of variables. Other well-known Mira type variables include R Leonis, which is in the constellation of Leo, and a very famous star called R Leporus, which is also known as Hin's Crimson Star, in the constellation of Lepus the Hare, but there's tons of them. There's variables that change just because one star is hiding one another. So it's not a physical process. And then there are eruptive variables where you have irregular timed explosions that are occurring on or near the star. So it is a wonderful organization to be involved in. I'm a member, have been since 1982. And you can contribute your observations, which can become part of a light curve like this. And I've got some dots in there, Debbie. I know
Right.
some of those dots, those are mine.
Yeah. So if you look at this image close up, you can tell that it's made of all these little dots. And it's like those are observations from people who are tracking these Mira type variables, or in this case, Mira.
Myra, in this case, with just their unaided eye, they can just look up,
Right.
contribute the observation, and then a professional astronomer will come along and use these light curves to try to suss out the behavior of Myra, the future behavior. So you're contributing to science by making these observations.
And it's not always the same, right? Like you can see that a couple of those peaks are higher, and there's one that's much lower over on the left side of the graph. So tell us about that. It's a little different every time, right?
Yes, there's always this element of surprise with Myra. When it's peaking, when it reaches its higher peaks, it's as bright as the Big Dipper stars or the North Star. When it's lower, it's a level fainter. So, and that has to do with all kinds of internal physics things happening within the star. And also, Myra stars are not necessarily spherical. They are distorted in shape. They have really weird shapes. They're bright areas, darker areas. They puff out soot around themselves. And this causes the peak magnitudes, the peak brightness from cycle to cycle to vary.
So here we're looking at three stars that are somewhat. These are artists' illustrations, but this illustration is depicting three red giant stars. So Myra is a red giant. Tell us, like, why, like, what's going on inside of it that's causing it to expand and contract? Like, what's making it so unstable?
Well, when a star becomes a red giant, it's switching its fuels, what it's burning to create its energy from the core to a layer outside the core. Sometimes you get multiple layers outside the core that are burning hydrogen or helium, and all of these different burnings, switching on, switching off, cause the star to become unstable in a way, the star to become out of balance. And it drives processes like these pulsations. Other things happen too, but this pulsation thing with Myra is a sign that its life as a star, it's aging as a star, so it's become out of balance. And there's a lot of detailed physics that go into this and modeling, where we're trying to understand exactly what causes the pulsations.
And here's another very famous red giant star, the star Betelgeuse, which is it's also very unstable and will someday explode. When it does, we might see it brighten dramatically in our sky. So everybody's waiting for Betelgeuse. Could be tonight.
Could be tonight. Could become a supernova. And I should mention, Debbie, that Betelgeuse is also a Myra star. It has a lot of other variations.
I didn't know that.
Too, but it also has Myra-like pulsations. So it does share similarities with Myra.
Wow. And our sun will become a red giant someday too, won't it?
Yes, we are lucky to be alive in the era when the sun is a nice stable, it's at its equilibrium. Gravity is balanced by the outward pressure of burning. Burning in the sense of nuclear fusion, because the sun is fusing hydrogen at its core like a giant reactor to create energy. So there's the sun now. In 5 billion years, the sun will run out of hydrogen to burn inside of its core. And when that happens, the center will contract. It'll heat up, and then hydrogen burning will begin in a ring around the core. And that burning will puff out the outer layers of the sun and create an enormous red giant. It's just kind of waiting for that time that burning, the shutdown and the burning will cause it to expand rapidly. It could become even big enough to engulf Mercury, Venus, and potentially the Earth 5 billion years from now. Not a scenario.
And yeah, well,
but exciting nonetheless.
Something tells me we don't need to worry about that.
We won't.
True. Yeah. And so when that happens with the sun, is it going to be expanding and contracting the way that Myra does?
That is a really, really great question. I spoke with Byrd, who is the staff astronomer over at the AAVSO, and he says that there's a good likelihood that would happen. Stars like the sun, the class of stars like the sun, should become Myra pulsators, expanding and contracting, but each star is different. Each star is an individual, and there is some doubt whether the sun will, there's no doubt the sun will expand and become a red giant. Whether it will become a Myra-like star, there's still a bit of a question about that, whether it will happen.
Let's move to this image. And I wanted to open it up for questions. So if you have a question, please write it into the comments, and Bob and I will try to answer you if we can. One or the other of us probably can on most things. And while we're waiting, we wanted to show you this image of Myra, which is from NASA's Galaxy Evolution Explorer, aka GALEX, back in 2006. And GALEX was an orbiting observatory that looked at the universe in ultraviolet light. So this spacecraft let astronomers discover something amazing. And Bob, tell us about this image.
Well, one of the really cool things about Myra is when it's expanding, it's releasing material into space. elements and compounds that it's created through fusion reactions and other kinds of reactions within the star. It releases it as hydrogen, as dust, and other gases. In the meantime, as it's doing this, the star is also streaming through space at a very high speed. And so this material, as the star passes through what we call the interstellar medium, which also has its own gases in it, they collide and start to glow. And they create this beautiful comet-like tail behind the star. It's really a dynamic image in that sense, Debbie, because you can picture the star zooming through space here because of that tail of shed debris from the star.
So this is Mira, looked at a different wavelength, and it's moving, as Bob said, very rapidly through space. It's moving at something like 130 kilometers per second. So it's moving really fast through space. And did you mention the bow shock?
Yeah, go ahead. It's like a boat moving through water, right?
Yeah.
Exactly.
Right.
It creates kind of the waves on either side, a bow shock. It's what you're seeing are sort of the similar thing, are waves of material around it.
And and this tail that's trailing behind Mira as it zooms through space is 13 light years long.
That's
13 light years.
Yeah.
So the closest star to Earth is 4 light years. So it's 3 times farther than the closest star to Earth.
Yeah, 3 times farther than the Alpha Centauri system. I mean, that is incredible. And you think about, I don't know how many billions of tons of debris are in there, but that material is essential. Stars that age like Mira stars, and the sun too, ultimately, give back things that they create within their cores, give back some of that into space. And those elements and compounds, they are regathered at a future time, recompacted, perhaps through a supernova explosion, like what we expect to happen with Betelgeuse, recompacted to form clouds of dust and gas, which ultimately give rise to a new generation of stars. So you're seeing kind of like almost a first step in the creation of a star here, as Mira loses material, sheds it into space.
And not just stars, but also people.
Like you, like our listeners and the viewers. Like, yes, exactly.
Star people.
So we are star people. And as Debbie, you and I joked just before the show here, I told you I have little pieces of Mira variables inside my atoms right now. I know that I can feel some slight pulsations. I feel the energy of the generation of stars that had to live and die so that you and our beautiful planet Earth could be here.
And, you know, like every time that you see something about Mira online, it always talks about that it's moving so fast and it's moving at 130 kilometers per second. But the sun is moving at 230 kilometers per second. So the sun is moving through space faster than Mira, but the sun probably won't form a tail like Mira's. Do you want to talk about that? You want me to talk about it?
I think because everything is moving along with the sun at approximately the same rate, whereas Mira is sort of on its own trajectory behind. If you want to elaborate, please do, Deborah.
Yeah, no, you said it just right. So the sun is just moving more gently through its environment because it's moving along with everything else in its environment, right? Whereas Mira's not. Mira's more like cutting across something different to itself.
It's like cutting in line, isn't it? Something like that. The star Arcturus is like that too. It's also moving against everything around it, environment. So it's zipping through space in a different direction. So yeah, there's all kinds of stars like that.
That's why the sun won't, even if it becomes a Mira variable, which we don't know if it will or not when it reaches the red giant stage, but if it does, it probably won't develop a tail like this because it's not cutting across stars and gas in its environment.
But it will be mighty big in that future era. And should there be any descendants of our species 5 billion years from now, I'm sure we will have moved off the planet and gotten away safely to Jupiter or one of its moons, where the conditions will be a lot more clement 5 billion years from now.
Okay, so no questions. We hope you guys will start asking questions on one of these live streams. We really want to answer your questions because we really are here to help you learn to love and appreciate astronomy as much as we do, Bob.
Yes, absolutely. And the stars by themselves are beautiful to see, but when you start picking them out individually and you start to learn about them, and Myra's a tremendous example because it's a star, once you identify it, you know where it is, you can actually see it change with your eyes over the weeks and months to come. And there'll come a time when it'll be invisible and you'll be like, wow, that star used to be there. Of course, it still is. And then you will have experienced this rhythmic contraction and expansion of another star light years and light years away from the Earth. It's a wonderful journey of exploration.
That's beautiful, Bob. Thank you so much. Thank you for being here today.
Oh, it's really been a pleasure. Thank you so much for having me, Debbie.
We'll have you back soon.
Great.
Wait, so how can people find you?
Oh, they can find me on Facebook. I do regular postings on astronomy for everyone, AstroBob's Astronomy for Everyone. I also write for Sky and Telescope's website and magazine.
Thank you, Bob. We'll see you soon.
All right. Thanks a lot, Debbie.
So we've been talking about the star Mira in the constellation Cetus. Bob called it the sea monster. I usually call it the whale. Mira is really a beautiful reminder that change is a constant in our universe. And if your sky is clear tonight, we hope you'll step outside and try to find Mira for yourself. And again, we have more charts that'll help you star hop from some easy to see things to Mira at earthsky.org. So that link is in the post description. We hope that you will try to see this wonderful star. Thank you so much for joining us. And hang on, let me look. Someone said it's amazing and unbelievable. It is. It's amazing. It's amazing stuff. Thank you, Tony. And someone else said, thank you for the stream. You are so welcome. It's our pleasure, really. Let's see what else. Thanks for a great presentation. Use C-star to find Mira and saw it as roughly equal to Gamma Ceti. Awesome. John, thank you. Thank you so much for being here. So thank you, everybody. And we will see you very soon. And I'll be back next Wednesday to be talking about the great planetary syzygy, the great lineup that happened earlier this month, and about what will be happening with those planets next. I hope you'll join me then. One Earth, one sky, EarthSky.